Hi, you're listening to Avril Sauter talking about CCNA Wireless. In this lesson, we're going to talk about the Cisco Unified Wireless Architecture. And we're going to begin that conversation talking about autonomous mode access points. And Cisco actually expect that for a unified wireless architecture, you would actually transition from autonomous mode to lightweight mode. So we're going to talk about lightweight mode of operations, and we're actually going to show you how you can convert from autonomous mode to lightweight mode in order to transition to a unified wireless architecture. Now, if we look at the basic architecture of an autonomous mode access point, depending on the model that you've acquired, it will support all of the 802.11 radios, A, B, G, and N. It may operate in a single or a dual mode operations. If it's operating in dual mode, it'll operate both in the 2.4 and the 5 gigahertz band. A single mode may operate in the 2.4 or the 5 gigahertz band. Just as an FYI, if you're buying an access point for a small business or home market, and so you're buying one of the lower cost access points, and this isn't so much for Cisco but just in general, if you're looking at acquiring access points, just be aware that there are dual mode access points or multi-mode access points, and sometimes they will support simultaneous operations both in the 2.4 and the 5 gigahertz band, and sometimes you have to choose. So it'll support both but only one at any one point in time, and so you either have to configure it for the 2.4 or the 5 gigahertz band. Increasingly though, the newer access points are really supporting a dual mode operation, so you can simultaneously support the operations in both 2.4 and the 5 gigahertz band at the same time. One of the biggest mistakes I see in the industry is where people buy an autonomous mode access point planning to use its PoE, and then they forget to upgrade the switch, and the switch doesn't support PoE, and they either have to go and replace the switch or they have to go and buy a power brick or an injector for that access point. Now, the main thing about autonomous mode access points is they operate as a standalone device, and so their layer 2 operations is standalone, and so you have to go out and configure it. Now, the advantage of having a standalone access point is it's simpler in the sense of if you've only got one or two you have to deploy to get them up and running fairly quickly. It's fairly inexpensive simply because you don't need any additional network devices such as a wireless LAN controller. Now, they will run the Cisco iOS operating system, and you can have them operate in different modes. So you can have it operating in the normal access point mode where different clients are connecting to it. You can have it operating in a bridge mode where you're using the access point to interconnect different wireless LAN segments. You can have it operating as a wireless repeater. In a repeat mode, it relays the same information to the next wireless node. Or you can have it operating in a scanning mode where it's not talking to any clients, it's just listening. So it's listening to the RF environment. And what is really very good is for detecting rogue access points and giving you a list of MAC addresses of devices that are out there, and then you can make decisions about what you want to do with those devices. Now, the main thing about an autonomous mode access point is that you have to configure it locally, and therefore the configuration is actually stored in the access point. Now, I have seen in some environments where they don't secure the access point very well, and you can just plug in an Ethernet cable into the back of the access point and reconfigure it. So you have to be careful keeping the configuration locally in the access point to make sure the access point is secure, that someone's not going to go in and tamper with that configuration. If you're in a lightweight mode, then the wireless LAN controller forces down the configuration, so configuration changes, which means if anybody was to try and change the configuration of an access point using an Ethernet cable just directly plugged into the access point, that would therefore be overwritten from the configuration coming down from the wireless LAN controller. If you have an autonomous mode access point, it does have full functionality, which means that you could use that access point to do your authentication and your over-the-air encryption. And if you have an access point deployed at home, that's probably what you're doing, is when you connect, you're using the authentication and encryption capabilities locally stored in the access point. Some of the terms that you'll hear about for this access point, you'll hear it referred to as a thick or fat, and that's simply because it's fully functional and sometimes called an intelligent access point. Now, these devices are managed individually, as we've discussed a couple of times, but there's different ways that you can manage these devices, and some of them are actually quite effective interfaces. So you could go in through the command line interface, through the normal mechanisms, i.e. you can go in through the console port, you can go and telnet or SSH to that device. Once the device is actually on the network and has an IP address, you can also go in through the web interface. Now, just so you know, is that you can give your access point a static IP address, which means that you can actually go directly to it plugging into the Ethernet port. You don't need to go through a switch or a router to connect to it, but quite often you'll put your access points up on the network, they dynamically get an IP address, and then you can just go through the web interface to configure that access point. And that's what you do once the access point is deployed. You can also use the wireless control system to help you migrate those autonomous mode access points to a lightweight mode access point down the road. And there's also third-party software that you can acquire that can help you manage autonomous mode access points. The main thing here is that it is managed individually. So if you've got 3 or 4 or 5 access points and you want to make a configuration change, you have to configure each one independently. And of course, if you start making a lot of changes and go to many access points, this can become extremely time consuming and very high prone to errors. Like if you're making major configuration changes and each one's individually done, you can run into some operational errors. And so the larger you become and the more changes that you're making to your network, the more desirable it comes to move away from autonomous mode access points to lightweight mode access points. So I want to take you through how the data flows through the network. So here in step 1, a client will transmit a data frame to the access point. When it transmits that data frame, it's going to have an 802.11 MAC header on it. And that MAC header will have the source and destination MAC addresses, and it will also have the MAC address of the access point. If we assume that the access point successfully gets that data frame, what it's going to do is it's going to rip off the 802.11 MAC header and attach another MAC header for it to go across the wired network. And in this illustration, it's going over an Ethernet connection, so it's going to add an 802.3 MAC header. And that MAC header is going to have an 802.1Q tag inserted in it. And that 1Q includes the VLAN tag. And in this way, the receiving switch says, oh, this is going across this VLAN. If that access point has multiple SSIDs, then it's going to include in the header going over the wired connection from the access point to the switch an 802.1q tag, which includes the VLAN ID. Now, if you are using multiple SSIDs on your access point and mapping them therefore to multiple VLANs, it's really important when you configure that switch that you limit it to only the VLANs that are defined on that access point. And if you're defining multiple SSIDs and multiple VLANs, that enables you to define different interfaces. So you can have, for instance, an SSID for employees with one encryption method and an SSID for guests with a different encryption method. If you don't do multiple SSIDs and you don't do VLANs, then you can only choose one encryption setting, one interface for your access point. So we've encapsulated our frame and sent it over the Ethernet connection to the switch. Once the switch has it, it can look inside of the header where it sees the VLAN ID, and then it will route it according to that VLAN ID. So now we know how autonomous mode access points work. Let's take a look at lightweight access points. From a radio perspective, a lightweight access point supports all the same capabilities as an autonomous mode access point. So depending on what product you bought, it would have an A, B, G, or N radio. It could be a single or a dual band radio, and it would be powered in the same way, i.e. you'd power it locally with a power brick or power injector, or you'd run power through the Ethernet cable. The difference is in the Cisco unified wireless architecture, the lightweight access points are managed centrally. And when I say central management, I'm not just talking about the configuration, I'm also talking about all of the statistics about running the access point is fed back to the wireless LAN controller. So we're talking about RF information such as the interference and coverage. We're talking about client data. So everything is being transmitted back to the wireless LAN controller and handled there rather than at the lightweight access point. So the way to think about it is the layer 1, the physical layer, your radio is at the access point, and then the MAC layer, which is dealing with the access to the RF, the creation of MAC headers, that functionality is split between the access point and the wireless LAN controller. The access point can function in various modes, just like we saw with the autonomous mode access point, but I have a couple of additional capabilities. So I can operate in a local mode, which is the normal access point. Clients connect to me, and then I forward that data now to the wireless LAN controller to then send on its way. It can operate in an HREAP mode. This is where I want to deploy the access point out in a branch or remote location, but I don't want to put a wireless LAN controller in each location because of the cost, and so that will connect back to a wireless LAN controller located in my central location. It can operate in a monitor mode. Monitor mode allows me to be continually scanning the RF, so I can identify things like rogue access points. But because it's in a lightweight mode, I can actually feed that information back through my wireless LAN controller and actually do much more sophisticated intrusion prevention techniques. I can operate in a sniffer mode where I'm listening to packets going over the network, as opposed to monitoring mode, which listens to the RF. Now, depending on the access point that I've acquired, you're going to see some more advanced features capabilities if you're using a lightweight access point. And one of them I just mentioned would be the ability to do intrusion prevention. Another would be location tagging, and also radio resource management. I can connect to the lightweight access point using various techniques. I can go through the command line interface using either the console port, or I can telnet or SSH to that device. I can also go through the wireless LAN controller GUI in order to see what's happening on that device. And I can also see, things like if the device up and down going through the wireless control system. And so that was an example where going into the CLI and looking at the debug messages and literally looking at the access point and the wireless LAN controller talking to each other, I actually found that a little bit easier to debug than just going through the wireless LAN controller interface. So if you look at this picture, on the right you have the wireless LAN controller, and that wireless LAN controller is going to be pushing the configuration and firmware which is stored in the wireless LAN controller through to the access point. And of course you'd have multiple access points connected to that wireless LAN controller. And when it communicates with that access point, it's using the LWAP protocol, and more recently what you're going to see is the CAPWAP protocol. Now the advantage of this mode of operation is that the wireless LAN controller is actually controlling, as the name would suggest, in a central way, multiple access points. Now when you introduce a wireless LAN controller, it does add complexity to the network, because you now have to work out, where do I place my wireless LAN controller? How do I configure it? How do I make sure that my access points can set up a secure tunnel to it? Is it going to be on the same subnet? Are they going to be on different subnets? And so you're introducing more complexity in getting this configuration up and going. Once you've got it up and going, it becomes a lot easier to actually scale out your network. So let's say you want to expand your network, you want to expand your coverage. You can very easily do that. Now for a small network where you've got a few access points, adding a controller and spending the time getting that controller up and working, it'd actually end up being more expensive than if you just had autonomous access points. But at some point in time it actually becomes less expensive to have a wireless LAN controller, because even though you're paying for the box, the operational cost of managing the different access points becomes prohibitive. And so somehow you have to find a balance as to, for this particular business environment, this one would be better off with autonomous ones, this one would be better off with lightweight. And it's not a simple thing as saying anything over 5 access points. It's much more complicated than that. You've got to look at what kind of IT support they have, how quickly can they get this up and running, how often do they anticipate the access points will change. My personal view is, as soon as they get to a network that's got about more than 4 or 5 access points, I prefer to go to a wireless LAN controller and prefer to manage it in that environment. Now, autonomous modes were sometimes called thick or fat access points, so lightweight access points are sometimes called thin access points. So if you ever hear that term thin, you should be familiar with that. So let's begin talking about LWAP, Lightweight Access Point Protocol. So it is a Cisco proprietary protocol. It was actually approved as a standard by the IETF, but it's really not been very popular. And so the evolution of LWAP was to CAPWAP. And that's really what you see as the standards-based solution. And so most people consider LWAP to be proprietary, even though strictly speaking it did become a draft IETF standard. Now it operates at 2 layers. So it has 2 modes of operation. It has the layer 2, which works only on the data link, so layer 2 data link. Even if you have an IP connection, in layer 2 mode it only operates at layer 2, which means it's operating on the individual link. There is also a layer 3 mode, in order for layer 3 to work, you must have the IP layer 3 network in place. Now, the way to understand this is think about the access point effectively does the real-time MAC processing. So that is things like the beacon frames, sending out responses to probe requests. And what is done at the wireless LAN controller is the processing that doesn't have to be real time, i.e. isn't critical for access to the RF resources. And so that would be things like authentication, mobility, and roaming. And so in order to send that information that's needed, like authentication, back to the wireless LAN controller, you need to set up a secure tunnel. And so we set up a secure LWAP tunnel. And if we're sending control information, it's sent on the UDP port 12223. And if we're sending user data, then it's sent on the UDP port 12222. CATWAP stands for the control and provisioning of wireless access points, and it is based on the LWAP. It's very, very similar to LWAP, but it operates at the layer 3 only. And it uses different UDP ports. CATWAP will use port 5246 for the control information and 5247 for the user data. Now, the CATWAP protocol is actually included in any wireless LAN controller that's release 5.2 or later. Prior to 5.2, controllers only use the lightweight access point. And so make sure when you're deploying your access points and looking to deploy CATWAP that you do make sure you're running on a very recent wireless LAN controller release. Now, you can deploy CATWAP controllers and LWAP controllers on the same network, so it's not like you have to transition all of your network to CATWAP. And a controller that's supporting CATWAP will actually let access points connect that can run LWAP. Now, there are some access points that when the controller detects that is capable of running CATWAP, that the controller will say, okay, you have to use CATWAP. And they will be access points like the 1140 series and the 3500 series. If you try to connect those and want to use LWAP, you'll get a message back saying, hey, you need to use CATWAP because you're CATWAP capable. And so if you've got 1140 series or a 3500 series access point, make sure your controller is CATWAP enabled. Now, a CATWAP actually has two modes of operation depending on your deployment environment. The split MAC was what we were talking about, is when you have a central access point. The split MAC is what we were talking about when you have a central wireless LAN controller. The local MAC is when you're deploying the access point at a remote branch location, and you have two choices here. You can either tunnel back all the data back to a controller, or you can actually say, hey, why don't I just send that local traffic from the access controller out to the network rather than tunneling all the way back to a controller in the central headquarters location. So the local MAC HREAP approach actually allows traffic to be tagged with your 802.1q, where I can put in my VLAN information just like we talked about with the autonomous mode access point, versus the split MAC where all of my traffic is going to go back to the wireless LAN controller. So we looked at how an autonomous mode access point sends data through the network. Let's now take a look at how a lightweight mode access point does that. Well, first, the client device will create a MAC frame, an 802.11 MAC frame, and send that over the air to the access point. When it arrives at the access point, unlike an autonomous mode access point. This time what's going to happen is the access point will encapsulate that data frame, i.e. it will add an additional header to it. It does not remove the 802.11 header. It puts another header on top of it, and the header it puts on is an 802.3 Ethernet MAC header, because it's going to communicate over the Ethernet network from the access point to the wireless LAN controller. It then sends that MAC frame to the wireless LAN controller using an LWAP CATWAP tunnel. It's then going to send that 802.3 Ethernet MAC frame to the wireless LAN controller using the LWAP or CATWAP tunnel. Now, if you ever look at the message exchange between an access point and a wireless LAN controller when it's setting up this tunnel, you will notice that it actually enables the Datagram Transport Layer Security Protocol, DTLS, and this is actually the type of tunnel that's actually set up. And by setting up a tunnel between the access point and the wireless LAN controller, I can make sure that all of my frames leaving the access point all go directly to the wireless LAN controller, independent of whether there's switches or other network nodes in between. When my frame arrives at the wireless LAN controller, I will throw away the 802.3 Ethernet frame header, and inside I can see the 802.11 MAC header. That header will tell me information such as 802.11 quality of service, whether it's a data frame or an authentication frame, etc. So it tells the wireless LAN controller how it needs to be processed. If it's a data frame, as we're using in this example, and we want to send it out and onto the network, what's going to happen is it's going to take off that 802.11 MAC header, and it's now going to replace it with an 802.3 Ethernet header in order to go across to the next link. Now, the wireless LAN controllers would typically be connected to a switch using a trunk port, as shown in this illustration. And what we're going to do is we're going to insert into that Ethernet 802.3 header our 802.1Q tag, which includes the VLAN ID. So what you're seeing here is, in comparison with the autonomous mode access point, the wireless LAN controller is the one that adds the VLAN tagging information. It then sends it to the switch. The switch then looks at that VLAN ID information and then sends it on its way using the appropriate VLAN. So in our demonstration, we're going to take a look at how do you convert from an autonomous mode to a lightweight mode. So I've brought up PuTTY and I've got my console cable connected to the access point, the 1142. And so the first thing I want to do is to take a look at the version. So here you can see that I'm running version JA at the end of it. And again, you can see that it's got the 1140 software on there. So the next thing I want to do is make sure that I can reach my server. So I'm just going to ping it. That's great, so I can reach my server. So now I'm ready to update the file. So the command is just archive, download software, force reload, overwrite. I'm overwriting from the TFTP server, and I want to now tell it where the server is. So it's 192.168.60.4, and now I need to give it the file name. And I've cut and pasted this so I don't make any mistakes on it. There we go. Let's just make sure. Here you can see it's JY. So yeah, everything's looking good. I'm going to hit the Enter key. So it's completed. So let's go and take a look at our version. Okay, to show version. And you can see here that in Flash I now have my new image. And it's really as straightforward as that. Now you want to make sure that you've set up your ports, etc., to make sure you're going to get IP addresses, etc. Here I'm in my lab, so my access point is just on the desk, so it's very easy for me to change images. If I was doing an installation and it was up on the ceiling, then I'd want to make sure that I had set any IP addresses, any port information, so now it can go off and use DHCP to get the right IP address and then connect into the network. So I hope you found this of value. It really is that straightforward. The main thing here is to make sure that the file is on your TFTP server and you key in the right name of the right file. And so always double check your server's accessible, always double check the name of your file, and do what I did, just cut and paste it across so that you don't make any mistakes. So let's look at the LWAP, CATWAP process of how do I actually go about getting my access point to communicate with my wireless LAN controller. Let's quickly compare LWAP and CATWAP protocols. We discussed that LWAP is proprietary Cisco protocol, so even though it's a draft IETF, most people consider it a proprietary protocol, whereas CATWAP is used by multiple vendors and is an IETF standard. CATWAP only operates at the layer 3, whereas LWAP originally operated at the L2 layer only, and then it was modified to support at the L3. Now if you deploy LWAP at the layer 2, then it will be restricted to the layer 2 boundary, and that's really why you really want to be up at the layer 3 so you don't have that restriction. So they both support a local MAC and a split MAC so that you can operate a remote branch and not force all of your data traffic through the central headquarters when you have a remote location. They both support the separation of the control and the data traffic. Now, one of the big differences is in how they set up the secure tunnel. CATWAP uses DTLS that I mentioned earlier, whereas LWAP uses the AES CCMP, which is the Advanced Encryption Standard Counter Mode CBC MAC protocol. I mentioned earlier that it is possible to support both CATWAP and LWAP. However, it would be recommendable that you move to CATWAP in entirety at some point in time. So it's quite possible during a transition period you're going to have a mixed environment, but you really want to be able to convert completely over to CATWAP in order to improve the efficiencies of your network. So let's take a look at the CATWAP protocol, and let's start with some terminology. Firstly, the CATWAP standard uses the term access controller, which is the same thing as the Cisco wireless LAN controller, i.e. is a controlling box that's managing a collection of access points. The wireless termination point is what we refer to as access points. They are the location where the client transmits and the radio piece terminates before it starts communicating on the wired network. The CATWAP protocol defines a number of messages that go between the access point and the wireless LAN controller. They include things like the discovery, join, we'll talk about those in a moment, that help me connect between the access point and the wireless LAN controller. There are control messages for downloading the firmware, downloading the access point configuration, also notifications and alerts going between the two. So it really defines a full suite of protocols of how these two boxes will communicate to one another. Now the flow of traffic between the access point and the wireless LAN controller is separated into a data channel and a control channel. Clearly user data goes in the data channel and control information goes into the control channel. Just as a little FYI, if you're ever troubleshooting, because these are encrypted tunnels, it is actually possible to turn off encryption on the control channel so you can actually troubleshoot problems with it and actually read those messages. But normally once it's transmitted into the DTLS tunnel, then it is encrypted as long as the control and the data. So in the split MAC architecture, and remember that's when we're splitting the MAC functionality, real-time data on the access point, and moving back everything else to the wireless LAN controller. So in a split MAC environment, all data is sent through the CAT-WAP tunnel to the wireless LAN controller. The access point handling things that really require real-time attention. And when we talk about real-time attention, it's really to do with how quickly they can use the RF resources. So things like beacons, if I get a probe request, how quickly I respond back to it, processing my incoming frames and sending out acknowledgements, etc. And then everything else I want to move back to the wireless LAN controller. So anything that's not to do with using my RF resources, then I move it back to the wireless LAN controller. And that will be things like authentication, association. And remember, the wireless LAN controller, this is when I will then say, let me add my VLAN ID for different SSIDs to then go different directions across the wired network. The local mode is really where I have a remote access point called a remote edge access point, a REAP. And again, this is great for branch locations, remote buildings where you don't want to put a controller. And so I'm going to tunnel that from that access point into my central controller. But it doesn't always make sense to send all the data across a link between my branch location and a central location. So for instance, my branch could be located hundreds of miles away, a different state. I don't want to be tunneling that information back to a central controller because it's going to use valuable leased line resources. And so what I want to do is I want to tunnel back the control information, so I'm controlling the configuration out at the branch location, but my user data can go directly from the location out to the internet, etc. And I only tunnel back control information. Now, to improve responsiveness, etc., because the expectation is that I'm tunneling back over a lease line back to a central headquarters, and that lease line may not be a very high data rate, then what it will do also is it will act as a local proxy. So it can locally associate, locally authenticate. That also enables me to continue operations in the branch should I lose physical connectivity between my branch location and a central headquarters location. Now again, that's referred to as the local MAC mode. So now we have a good understanding of the terminology. Let me just wrap up this section and remind you a couple of things. LWAP stands for Lightweight Access Point Protocol. It was acquired by Cisco, so it's a Cisco proprietary protocol used for configuring lightweight access points. Two modes of operation, Layer 2, Layer 3. The CAT-WAP protocol evolved from LWAP, is an IETF standardized protocol, also used for configuring lightweight access points. AC, an access controller, is a CAT-WAP term that was what Cisco referred to as the wireless LAN controller. And the wireless termination point, that's the CAT-WAP term for what we all call a lightweight access point. Thank you for listening.